Hello, welcome back. Let us now get into the solution of question 8 onwards. Maybe we'll cover these three questions which are in part A, then we can go into part B in the next recording. Now, what is this question A all about? Give the messages printed by the parent and child processes when the below code executes. You can assume that it works correctly. Why is this mentioned? Because only if you have a C code, only these instructions, pretty sure that it will not execute at all, because there should be a main, there should be a include statements, there should be some include statements which are relevant for this function calls, and we need to make sure that it works. So whenever a piece of code is given, you can assume that it works. Now the question is, what do you get when this executes? So I'm not trying to find here, missing semicolon or whether this is syntactically correct. Will it compile? If there is a question like that, maybe you can look for it, but that's very trivial. Where I want your understanding to be checked is, find out whether when this works, what will be the output. So unless you understand the concept of fork function call, it's not possible for you to answer this question. So let us now keep this question on the side so that we are not missing what is being asked. At the same time, let us try to understand what is fork. Now I need to give some little bit of history, not totally out of this context. First, let us understand what is a function call and what is pthread create does. Then we'll try to understand what does this fork do. So these are all three different ways of passing the control to something else. Now what is a function call? Let us take the same example of thread function, which has been covered earlier. Let us take that. Now suppose this is a normal thread function, which is a C function, of course, but we are giving it as an input to the, let me say this, okay, we are giving an input to this pthread create for it to be created as a thread. Now will it prevent me from calling this directly? No, I can say that thread function, as long as I pass some void star pointer, it should be okay, or I can even pass null. In that case, the pointer is passed as a null. Okay, null pointer is assumed to be a void star pointer, and it is, this function is going to be invoked. Now when I have a printf hi, and then I have another printf out, maybe I have come out. Now what happens when these instructions are executed? We call the printf, hi is printed on the screen, then thread function is called. That means it goes into the execution of entry of the thread function, and then it will execute whatever instructions are there. In case if this returns, then it will come back. Otherwise, if you put a while loop, while one here, it will maybe permanently there. So let us assume that we have put a return. In that case, it will come back here and then execute this printf out. So a function call is taking the control to a function, and then when the function returns, the control comes to the next instruction which is given below. So that's the normal function call which all of you are aware of. Now what is thread create? Now suppose the same function pointer, in fact I am telling that when you create a new thread, you are going to be giving the control to this function, whatever function I have, okay, this thread function. Okay, let me call this as a thread function. Now when I call this thread function, it's going to create a thread executing this thread function. So that is different from calling a function call. So let us understand the difference between a thread create being given the same thread function. Of course, as a function pointer doesn't matter. Now that means that this program, whichever is executing as a process, I will call this as a main thread, is calling a thread as an point to the thread function. What is the difference between calling a function call the same thread function and a thread function being given as a parameter to the thread create? Now what happens is when you create a thread with this, it actually creates a two different instances. That means this program can run, the main program can run in parallel to the thread being created. I can have any number of thread with the same thread function as an input. That means they all run in parallel. Suppose if I have a core with multiple CPUs, a multiple core CPU, then I will be able to run main thread here, another thread here, and another one here, if I have so many threads. But if I have a thread function, this main thread only will be running, and that inside that control, the thread function will also be executing. So this is not going to be running in parallel. But when I have a thread created, it is going to run the same code in parallel. And not only that, we are going to have the same function being executed multiple times. If multiple threads are there simultaneously, they will all be running the same piece of code simultaneously. It's equivalent to all your friends sitting together and reading one book. The book is there, pages are there. There, the book is equivalent to a code, and multiple processes executing them in parallel. That means they are reading the code and they are executing it. Maybe multiple CPUs are there, that's why it's possible to run it, otherwise it's not possible. In that case, they are all executed in sequence and in parallel. So that is the reason we are, while compiling this particular piece of code, normally in pthread create, we have to say reentrant. The function what we write is having a reentrant property. That means the same function which should be in a position to be executed by multiple threads simultaneously. So the compiler takes care of some issues to be taken care of when a piece of code is given to be executed in parallel. So this background of pthread create. Now what is a fork? So before I go into the fork, let me summarize. In the pthread create, we have only single process, and code is there, common code is there, common data is there, data, common code. That means all the threads are accessing the same piece of code and same piece of data, but they have individual stack. Okay, individual stack. That's the only difference between the process and threads. Okay, they run, the threads cannot exist without the process being there, and they execute in the context of the process. Now let us try to understand the fork. Now let us look at this code. Fork is a system call. There are no parameters to it, there is no return value to it from there. So this is one system call. When I say system call, that means application, we are writing an application, OS is there, it's entering the OS. That means you know that this is in user mode and this is in kernel mode. So when the fork is called, we are actually giving the control to the OS to do some job for us. Now what is the job that we are expecting the OS to do? Now I have piece of code which is running as a process. I said any executable is running it as a process. Now when the code encounters a fork, what happens is this process becomes 2 from that time onwards. From that particular instruction onwards, it has 2 copy. That means specifically in Linux, whatever I am going to say now is specific to Linux, because we are going to run this code on Linux, and the fork system call is Linux system call. Now when I have a process, so let us go back to the basics, and I have some process P, which this executable, I will show you some executable running also. It has got its own register, resident set. I said this one copy of it is available on the main memory. Okay, this is supposed to be a main memory. Now when I call a fork, what happens is this process already has a PCB entry. Let us assume that process control block entry is some 100. Okay, maybe 100 is the PCB. Now when I call fork, what happens is the PCB 100 is there, okay, which is parent, because the process which is calling the fork is a parent, and fork is meant for creating a child. What child? A process. It's not a thread. Remember, parent process calling a pthread creates a thread which runs in the context of the parent process, whereas a fork creates another process itself. It's like a dividing into equal two copies. Okay, and of course, if you need to create another process, you need a PCB entry. Though in Linux, even threads are having a PCB entry. In our fork case, anyway, it needs to have a PCB entry, new PCB entry. Maybe let me assume that it's some 202. Can some number which is more than this, because always Linux allocates PCB PIDs which are in the increasing number. So it is 2. So the original parent process is continue to be having the PCB and it continues to run, and the new process also starts from there. Now, one optimization taken care of by the Linux is, though your intent of calling fork is to create a new process, okay, it doesn't actually create a new image. Let me call this as a P1 or parent process. This is child process. It doesn't create a new set of copy for the parent child process immediately, but it allocates a PCB entry which is 202. So PCB entry is created and it is supposed to create a new process resident set, but it doesn't do it. That means then you may wonder, what will this new process which is being created at this point would execute? It will execute the same piece of code given in the original parent process. That means the child process is also sharing the process area, everything. Okay, it may have a separate stack, of course, but it will be sharing the same code and data area of the process. Now you may wonder, I said that only the threads will share the data and code of the process, whereas processes are two independent entities and they are not supposed to access each other's code. All that is true, nothing is wrong, but only thing is, for the moment, as long as the fork, now I'll tell you what more is, as soon as the fork is created, it is going to share. It's like a new baby born and it is going to share the parents' house and properties and everything until it becomes an adult and goes out and to live independently. So here the child which is created is like that, and it is going to share the same process code data area. Now in that case, how will you have two instances of execution? Because you need to have two lives. They need to be running on two different CPUs. It should be possible to, because I have two PCB entries, that means that they are schedulable entities which can run in parallel, and if you have a multiple core, they should be able to run in parallel. If that case, they should have a code that it can execute, because you cannot create a process and say don't execute anything, right? You need to give some piece of code. Here in the fork, we are not giving any function pointer. That means it doesn't know what to execute. So it executes the same code that is there. In that case, if suppose it has to execute the same piece of code, it should return. If it doesn't return, how will it come and then execute it? Like a normal function call. When you call a normal function, it returns and then it executes the next instructions below, right? Similarly, a process which is not given any input function pointer, and you are said that you are a separate entity now, you are supposed to execute now on your own, then it should have some execution set of instructions to execute. So we need to give the piece of code that it's supposed to do. Now what is done is that Linux implemented it this way. When the fork is called, okay, let me go to the code that I have shown you here. When fork is called, at this moment inside that if, there are two instances or two sequence of execution is going to happen. and that means inside the fork when you went in, it went in as a single process, but it will come out as two different processes. That means normal function call will return once, whereas fork function call, a system call, returns twice. And the fact that they are going to execute the same piece of code, they will wake up at the same place, but they have a different life now. They may wake up in any order because it depends on how the scheduler is going to schedule them on the CPU. If there is only a single core, only one process can run. So parent process also is going to be executed, and when it is scheduled out, the child process also will be executed. But when it executes, it is going to execute the same piece of code. It will wake up exactly at this point. Now the question is, when I wake up, when I start executing below, I as a process should know whether I am the parent process which is waking up from there, returning from fork, or the child process returning from fork, because I said that twice it is going to be returning. So when it is returning, it will return as a parent once and it will return as a child once. Now I need to be in a position to identify myself whether I am a child instance which is executing this below instruction or a parent instance which is executing the below instruction. So to differentiate between these two instances, what is done by the Linux is it returns, if it is a parent instance, it will return the child ID, PID. And the same fork, okay, I am writing it again, don't think that it is a different fork, the same instruction fork, because I can't overwrite on the same place, I am writing it here. It will return, if it is a child process, okay, parent process, which called this fork, okay, it is not a new instance, it is an existing instance which called this fork. Somebody has to call the fork, which happens to be the parent process. So when it wakes up, it will be returning with the value of the child it has created. Now when the child process wakes up, it will be given a value 0. Who is doing it? It is the OS which is doing it, because OS knows which is a PCB meant for child. So this piece of code is executed by the PCB which is newly created 202. Okay, and this is the process which is maintaining the 100 which I mentioned. So that is what is executing this code. Only difference is it is executing the same piece of code. Now let us understand this particular piece of code. If fork is equal to 0, that means the child process which has woken up. Now you may wonder why child process is given as 0. So let me give a reasoning for it. There are two system calls which you may be aware. Get PID is for getting the PID of the currently running process who is executing this system call. Okay, what are we doing when we call get PID? We are asking the OS, hey, please tell me what is my PID? What is my, it's like when you wake up from anesthesia, if you forget everything, then you may ask someone else, who am I? So a process, one way of asking who am I is get PID. What is my PID? Now the process may also be interested in knowing who has created me. Then it can ask for get PPID, parent PID. Then OS knows the relationship between parent and child, and it gives you whatever PID it is maintaining, that entry point of the PCB or the indexed into the PCB array. Okay, maybe. So that it gives you the individual unique ID, which is process ID, which is being maintained by the Linux. So get PID and get PPID will be able to help this child process to know what is its PID and what is its parent ID. Now what about this parent? After getting created a child, parent should be informed what child has been created and what's the PID allocated, because PID is allocated by the OS, and child, the parent process will not know until the OS informs it. Now you may wonder that why can't we have a get child ID, right? Why can't this Linux provided a get child ID, then I will get it. The problem is I am not sure whether I will be calling only one fork or multiple forks. I may call fork after fork. That means I keep creating child processes. In that case, if I call get child ID, what will it return? Will it return the child ID created while this fork was called, or will it return this one? So it is a confusion for the parent to know which fork function call created which child ID by child PID. So that is the reason, as well as another reason is that we need to be in a position to differentiate when it wakes up twice. We should be able to differentiate which is the parent instance of execution and which is the child instance, so that we can take some action based on that. So that is another reason. Another one is it needs to be informed immediately. Once the fork is done, child is created, that ID is returned. And if the parent wants to track the child PID, it should store it somewhere. If it ignores it, it cannot find out. Though OS knows which are the children created by this parent, it will not be the child process. Parent process itself will not be able to know which parent child PID was created and on which fork call. Okay, so now having understood that, you can easily say to just answer this question, which are the messages printed by parent and child process. Now the first message which is given will be printed by only the parent, correct? It cannot be printed by the child because child is created only here. That message 0 is only printed by parent process because child process does not exist before this fork. So after the fork, if it is equal to 0, it is going to print message 1. So child process will print only the message 1, whereas parent process will print this because it was there prior to the fork. Before the child was born, parent was alive. So it would have printed message 0 before calling fork, and as a parent instance, it would have got a child PID, which will not be a 0 because child PID, no PID value is 0, which is 0 is not a valid PID value. Okay, so child PID will be non-zero value. We are not bothered about what is the child PID. We want to know whether it is non-zero or not. That means this control, it will come only when parent process instance is executing this piece of code. So the answer will be child process. Now what are the messages printed? Parent prints message 0 and message 2, whereas child only starts living from after the fork, it will only print message 1. That's it. That's what you have to answer when this question is asked. Now, I will be stopping this recording with this question only because fork has been understood here, which will be helpful for you in the later part, which I will not be explaining again. Let me complete the reason why both parent and child are coming and executing the same instruction. This is only a theoretical knowledge that I want you to have, but we will be having another lab in the later, which will be covered in the later part of the course. What is done afterwards? So once we know the parent and child are executing the code, they will know what they are. So we can actually separate out the parent piece of code. If you want to actually execute a different piece of code for a parent, you can say parent piece of code can be split based on whether it is not equal to 0. Then you can go into the parent, whatever parent is supposed to execute, you can execute it, and if it is equal to 0, I can go into child part of the execution. Now I told that two processes need to be separate entities and they cannot change each other's data or each other code, but we are now telling that it is executing the same piece of code. Now when I say same piece of code, it also means that there are some data area which can be modified. Suppose if I have a local variable or global variable, I will be modifying it. In that case, even the parent can modify it. Parent instance can modify the data. Even the child instance can also modify the same data. Now, it is not allowed when two processes are there, even though they are parent and child processes, they are not allowed to modify each other's data. Now, the question is, we are executing the same piece of code, then it will be forced to change, access the same data, right? If I have a, what I am saying is, suppose I have a piece of code wherein I change the data. Suppose I have declared some integer a equal to 10, and then I say a plus plus here, and then I am also in the child part of the instruction, I do a plus plus. Now what happens, the same 10, the value of 10 is incremented here as well as here. That is not allowed. When one of the processes is executing some piece of code which changes some data of the original process, okay, if it happens, then what is done by the OS is, it will create a new copy of the same piece of code and data, okay, because we are having the same process, executable is same, so the same will be copied again, and then it will be, the child will be allowed to change its own whatever it is changing, and parent will be changing its own. Suppose a is equal to 2 to start with, now a equal to 10 we said. When parent executes a plus plus first time, it will be made to 11, okay, this copy will be made to 11. Now it doesn't matter whether the parent is trying to increment the value or child is trying to increment the value in its part of the code. If this is trying to change it, then it will be immediately stopped from changing the original parent's value. Then it will be given a copy of a again, which will be initially having 10, then a plus plus will take it to 11. Okay, so this will take it to 11. That means it is having its own copy of that a value 10 here, and whatever changes the parent has done, child will not know, child is not in, going to be affected by it. Similarly, even if child executes first a plus plus, child's changes are not reflected on p. So the summary of my discussion on fork is, fork, after the fork, same piece of code is executed until both the parent or any one of them, either parent or a child instance which is executing the code, trying to change the any data of the code of the program, sorry, not code, any data of the program, then OS will stop it, it will create another copy and then make them independent. Okay, so our original statement saying that each process are two different lives and they do not change in each other's area is still valid, but they execute the same piece of code is not a crime, because of course parent has created the child and child has to be given the program to execute, and it is for a moment when it is born, it is given the access as well as permission to execute the same piece of code, and even after copying it, it may execute the same piece of code, because code is not going to be modified. Remember, code is not going to be modified by both the program, even though they are running they are executing the same code. So fork system call takes care of that part of it. Okay, so they will be executing the same code, but each of them have their own life, and they, it's like each, a parent and a child have the common genes, but we live our own life, correct? So similarly these two processes live their own life, and parent process can die, child process will can exist, or child process can die, parent process can run forever, no issues. There is a relationship is there, parent child relationship, but they are two different entities, and it's not the case where pthread exit is not executed, if child terminates then the entire thing is vanished, or a main thread, if it doesn't execute pthread exit and it dies, then all the threads created by the process dies. So those things are not valid anymore, because it is two different processes and they are given different copies, and if one dies, it doesn't matter, other one will survive. Okay, it will be two different processes which is executing those same piece of code, it will be copied and then they will survive. Okay, I will not discuss about why this particular feature is provided by the Linux. It's called cow. Cow means copy on write. That means you are copying the parent resident threads into a separate one when either one of them, parent or child, tries to write into the data area of that parent process. So copy on write means you make a copy of the process when it is anybody is trying to change anything. As long as they are not changing, they will have only single copy. Why is it done? It is a very optimization, because if suppose both of them decide to terminate, then you don't have to have another copy made. So Linux always thinks in every aspect how to optimize the implementation without compromising on the correctness. Okay, fine. This is where we are stopping, and I think this is basically, this lecture is to give you a clear understanding of what is fork. Bye bye. See you in the next lecture.